Welcome to this lecture. In this lecture, we will learn, understand, study and implement the bag of word models in natural language processing. First, we will see what is bag of words model. The bag of word model is one of the most popular methods for extracting features from raw text. In this technique, we convert each sentence into a vector. The length of this vector is equal to the number of unique words in all the documents. This is done in two steps. It means these steps done in two steps. First, the vocabulary or dictionary of all the words is generated. And second step, the document is represented in terms of the presence or absence of all words. What is a vocabulary, or why we generate a vocabulary or dictionary? A vocabulary or dictionary is created from the unique possible words available in the corpus, means in all documents, and every single word is assigned a unique index number. In the second step, every document is represented by a list whose length is equal to the number of words in the vocabulary. The following exercise illustrates how bag of word model can be implemented using Python programming language. Now we do an exercise to understand bag of word model. Exercise: creating a bag of words. Number 1. Open a Jupyter or Colab notebook for writing code. 2. Import the necessary libraries and declare a list corpus or a list of corpus and add the following code in the cell. First, we import the Panda library of Python, and the second library we will insert is sklearn library, which is a famous machine learning library. We import the count vectorizer class from sklearn.feature_extraction.text package. Number 3. Use the count vectorizer class to create the bag of word model. Add the following code in the next cell. In this cell, we define a user-defined function whose name is vectorize_text and of corpus. Corpus is the parameter of this function. Now, next, we create an object of the class count vectorizer class. The object name is bag of words_model. Next, we call the fit transform function on our corpus. This variable store the result of our bag of word model when we apply on corpus, and toDense method convert the output of bag of word model into a vector. Next, we convert the output of bag of word model, which is stored in the variable dense_vec_matrix, to convert into pandas data frame. Pandas data frame means we convert our input into a tabular form for easy understanding and reading. And next, in next line of code, we sort our data frame by column wise. So column wise, and we use sorted function, which is a built-in function of Python. We use this function to sort and bag of word_model vocabulary attribute, which is used for sorting purpose, and then return this result bag of words underscore df. It means the bag of words model, the output of bag of words model returned in the form of a data frame. So we go in the next cell. In this cell we define our corpus. Our corpus is in list form. Actually in Python data structure list find. Our corpus has the following documents. This is our first documents, and this is our second documents, and the third documents is starts from here and here and end from this comma, and the last document is this natural processing is a part of data science. Actually this is our whole corpus. On this corpus we have to apply bag of word model and to extract features from this raw text or corpus. Okay, in the next cell we call the functions vectorize underscore text and pass our corpus as a parameter. So first run these cells. Okay, also run this cell and also run these cells. Okay, now I call vectorize underscore text function and pass our corpus and pass our corpus as parameter of function, and we run this. Okay, df. This is the output of our bag of word model in the form of a data frame. Our data frame is consist of rows and columns. Columns consist of unique words of our corpus, and rows consist of these words with frequencies or number of occurrences in each document. For example, in document number 1 whose index is 0, in document the word n occur one time similarly and one time, and similarly in document 2 or occurred 2 times, or its frequency in document 2 is 2 times. This is actually our bag of word models output. Next, number 4, create a bag of word model for the 10 most frequent terms. Add the following code to implement this. Now we define another user defined function whose name is bag of word bow underscore top underscore n, and its first parameter is corpus. We have already corpus of text in the previous cell, and then another parameter is n. N is basically tells the bag of word model function how many words have to return the function. Okay, first line is the in first line we create the object of counter vectorizer class, and we set the max features is equal to n, and then we convert the output of bag of word models into data frame, and then inside data frame we fit the transform function or our corpus and use toDense function for converting the output of data frame, output of bag of word models into vector form. And in the next line we sorted the output of bag of word model by using this line of code, and then return bag of words underscore df underscore small variable. It means the values stored in this variable. So return this user-defined function, and then we call this user-defined function, and then we pass our corpus, which we have already defined in this cell. This is our actually corpus on which we have applied bag of word model. Now we apply bag of word models, and 10 means we can only extract 10 words whose frequency is high, or more frequently 10 words. So run the cell. This is our data frame. In this data frame, we see those words who frequently occurred in our corpus. This is the output of our bag of word model. So thank you very much. See you in the next lecture of natural language processing.